Ses geliyor mu acaba? Nasıl anlayacağız?
Ses geliyor. Şurada bir ses geliyor ya.
Çıkartacağız.
Yok onu çıkartmıyorum. Tamam.
Bunun mikrofon ayarlı.
Bundan mı geliyor?
Bundan mı geliyor?
Evet.
Evet, çünkü onu ayarladık ya.
Şuradan sen konuşursan bir şey kaynıyor mu?
Tamam, anlıyoruz.
Görüntüleyen yokmuş zaten şunu rahatsız. Görüntüleyen yokmuş. Gitmiş midir sana? Gitmiş midir?
Sabah uyumuştuk.
Sana denk gelmiş mi de gidiyorum ki? Şu anda başlamadım. Yayında görünüyor şu anda. Sen hala şey mi görüyorsun? Adres şey mi peki? JYC5 görebiliyor musun yukarıdaki adresi? Tamam, o şu anda şey görünüyor, başlamış görünüyor şu anda.
Can sayfasını yayınlarsın.
Bir daha sayfa yayınlar mısın? Şu anda görünüyor. Birazdan bir yayınlayacağız diyor. Oldu mu? Tamam, biraz geç başlatsın demiştim. Beyza sen konuşun.
Ses 1-2 deneme ses. Ses 1-2 deneme. Ses. Geliyor muymuş ses?
Hayır. Duyuyor musun gayet?
Ses 1-2 deneme.
Tamam, duyuyor.
Ses. Az mı?
Ben de yapıyorsun, bakacak o yüzden sesini vermek söyleyeyim.
Sesimiz geliyor.
Zaten şu an görüntülen yok değil mi? Sen görüntülen yok. Tamam. Tamam. Hayır, benim arkalarımda görüntüleyen yok. Görüntüleyen yok diyor. Sen görüntülediğin nerede görüntüleyen yok diyor. Ona şaşırdım. Benim ekranımda da. Tamam, şimdi 3 görüntüleyen oldu. Tamam, şimdi oldu görüntüleyen. Tamam, teşekkür ederiz.
Çiğdem hocam iyi yaptın.
Tamam.
Canlı yayınlanacaktı değil.
Oftu'dan mı yani? Çiğdem'den mi yani?
Evet.
Şimdi başlayalım. Alalım.
Ön sıraları doğru alırsak.
Evet.
Ben kayıt yaptım. Şarkı alamayacağım. Şimdi ben katılmayacağım. Bana katıldığım yerine mi?
Arkadaşlar ön taraflara doğru bakabilirsek.
Ben de.
Benim görevim bunu yapıyorum.
So, good morning. It's my great pleasure and honor to have the chance to have 2 days with you jointly in the summer school on math education. And I guess you all have the program. And today we will focus in the morning, and we have a little bit longer lunch break. It was maybe a little bit too optimistic, half an hour. So we will have lunch break 1 hour, and then afterwards we will continue with teacher education, professional knowledge of teachers. And at the end, I would like to talk with you about what it means, scientific writing, and what mistakes can happen. And tomorrow, we will then focus a bit more on methodological aspects and on if we see the World Congress on math education coming up in the next year. If I'm speaking too fast, simply raise your hand. I'm trained to speak very slowly, but I've heard English is the language we are using here in your courses, so I can speed up or I can speak a little bit more slowly. So simply give me feedback at which speed I should start to talk. So I would like to start with teacher education. I mean, teacher education is a huge theme now all over the world. And when we started to study, we means, which is mainly the Sigrid Lönneke and Werner Lehmann, a very famous study. Nearly 10 years ago, teacher education was not such a big issue as it is now. So, the question is, what kind of knowledge do we manage to impart to our perspective of future teachers during the university study? I mean, that is the main problem. And the question is, of course, how effective is their study? I mean, that is a question we all ask ourselves while we are studying and while we are teaching. And there is quite a long tradition of this discussion. And I have brought with me a very famous quote by Felix Klein. You all know Felix Klein, very famous mathematician, and the first president of ICMAI, the International Commission on Mathematical Instruction. And actually, he wrote in, I should have corrected, in 1905, in his famous book, Elementary Mathematics from the Advanced Standpoint, in volume 1, he wrote the following. At the beginning of his teacher education, a young student faces problems which did not remind him at all on what he has worked on when he was at school. Of course, he forgets those things quickly and completely. But if then, after he has passed his exams, he starts working as a teacher, he shall suddenly teach exactly this elementary mathematics in a school adequate manner. He is nearly unable to connect mathematics in most cases. He will soon come back to the old-fashioned teaching traditions, and his university education remains more or less a romantic memory which has no impact on his teaching. I mean, that is a description on what was going on at this time at German universities. But we know that this is nothing which is typical German, and we know that it is simply we haven't overcome these difficulties. If you look, I have brought a few quotes with me from American researchers. Lawty said in 1975, teacher education is a low-impact enterprise. And Richardson said in 1996, teacher education is a weak intervention compared to own school experience and later professional socialization. And Zeitner and Tabachnik said in 1981, everything teachers have learned during the time of teacher education seems to be washed out by school experience. So you see, you are learning something, or we impart knowledge, we train our future teachers in a special way, and as soon as they come to the school, they forgot everything. Not because they haven't learned anything, but apparently because the school conditions are stronger than what we could teach them. So you see that it's actually the same critique Felix Klein formulated not now more than 100 years ago. So the effectiveness of teacher education, that means the question, how effective is what we are doing at the university, is yes, a research topic or only for a few years now. In 2004, we had a hot discussion in Germany where we said, look, there is not enough data around. We have no idea what is really going on in universities. We know a lot about schools. We know about PISA and TIMSS, what's going on in school. We know how our school kids are doing, but we don't know anything about our future teachers and how they are doing. So, and Oelker said in 2000 that it's not a crisis of teacher education, but a crisis of data. If you now go on a conference, and you will see it with English 13 next year, we have a lot of papers coming up about teacher education. Teacher education is now usually the biggest group at a math education conference or general pedagogical conference. Many studies are carried out, and really, there is really now not a crisis of data as it was 10 years ago, but it's now really a crisis of implementation of necessary changes. And it might be of interest to you that the German government has just implemented a huge and massive program in order to improve teacher education, not only math teacher education, but teacher education in general, with something about €500 million in the next 10 years. So I mean, it's really that teacher education should be in the heart of the university, and universities really should improve teacher education. So it's definitely necessary to implement changes, and I hope that the German universities at least will really be able to change their ways of teaching. So the study of which will be the core of this talk is about the TEDS-M study. TEDS-M stands for Teacher Education and Development Study, Learning to Teach Mathematics. And that is actually a study which was carried out in 2007 to 2009. Data sampling was in 2008. And it is a study which was implemented by the IEA. IEA means International Organization for the Evaluation of Education Achievement. That's a non-governmental body which is running, for example, the TIMSS study. And the critique about the inefficiency, actually, of teacher education was the reason for this TEDS-M study. So 17 countries participated, from Asia and from Western countries, and we had a few of the so-called high-performance study. We had from South America only one country, Chile, and we had from Africa only one, that was Botswana. In total, we had 23,000 participants, and that is really important. We had representative samples. So when we say something about German future teachers, then we can really say these are quite safe results because these were representative samples. Unfortunately, Turkey did not participate, but it would be really interesting to see whether there is some kind of replication here in Turkey. Germany participated with all federal states. Maybe you know that Germany has 16 federal states and you have to convince each state individually. What is measured is the teacher knowledge at the end of teacher education, whatever that meant. That means it was, of course, defined very differently at different parts of. At the end of teacher education means after 3 years study at some kind of seminary education, and in Germany it means actually after 7 to 8 years after university and an additional education. So we are really comparing very different kinds of education, but you want to know what do our teachers know when they start to enter teaching profession. So we have brought out published a book about internationally. I've edited this together with Sigrid Wilmeke and Fouray and Schmidt from VS, and you will find a lot of analysis about the study over here, which I cannot present in detail. So, and here you see the 2 German books, but I guess you would maybe like to read the English books. So actually what we had was, we had a preparatory study. And the main reason why the IEA decided in 2004, 2005, they had a preparatory study, which means we had the first discussion in 2002. I entered in 2004, this group, was the problem that you couldn't imagine that you can measure the professional knowledge of future teachers with multiple choice items. In more than now, something about 10 years ago, he said, how shall these items look like? You can't do that. It's not possible. And what kind of framework you should use? So IEA set up this kind of preparatory study. And it was originally called P-TEST, preparatory or pre-study, pre-study, and then it was called afterwards NT21, mathematics teaching in the 21st century, because it showed that it brought out own results. 6 countries participated. They had a 3-cohort design. That means we had first semester university students, and then teacher trainees. And we had a few supplementary studies, amongst other PhD theses by John Schwartz. And then we had a follow-up study, and actually I will talk about that in the next talk, in which we depart from the expertise research, and actually I had a book edited together with CPD on expertise in math instruction. And I will present results of the study afterwards. And it's actually, we really want to follow up the development of the professional knowledge, of the professional competencies of the teacher in their first years during teaching. So, first of all, I will concentrate on the TEDM study. TED's follow-up will be the talk, of course, embedded in more general reflections. So, TEDM study, I will describe the design and the framework, describe selected descriptive results of the primary study, secondary study, and then a few relational results. And then whenever you have questions, simply raise your hand. We are such a nice small group. So, I mean, you can raise your hand and say, look, I don't understand that, so you don't need to wait until the end of my talk. Okay? So, what do we understand by teachers' professional competencies? It's important to see that the current discussion on future teachers, on teacher education, and what is going on in the early career, with early career teachers, is now starting with a competence approach. Maybe you know that the competence approach was introduced by the PISA study, and they use this competence approach, and TEDS-M referred to Franz Weinert, a very German psychologist, and he said, or he described competency as the way how teachers deal with central professional challenges and tasks important in the teaching and learning process. It means everything concerning lesson preparation or diagnosing the students' errors. So the departure point is what are teachers doing within their professional activities. And we would want to describe that in more detail. So you may have come across this kind of conceptual model of teachers' professional competencies. So you have the general teacher competencies, and then you distinguish these kinds of competencies in two parts. You have the cognitive part, it means the cognitive abilities, everything what we call afterwards professional knowledge. You see that is the distinction between competencies and knowledge. You have the knowledge part, and then you may have heard about this very famous framework by Schulman, 1986, 1987, where he said, distinguish the professional knowledge of teachers with three facets: the content knowledge, the pedagogical content knowledge, and the general pedagogical knowledge. And actually he had another one, or instead of general pedagogical knowledge, he had curricular knowledge, and then he distinguished between content knowledge, pedagogical content knowledge, and curricular knowledge. In TEDS-M, we changed that to general pedagogical knowledge and included actually curricular knowledge over here. And then you have a very huge other part which contributes to teacher competencies, and that is the whole effective motivational characteristic. So it's everything concerning the beliefs. So what do you think how mathematics teaching shall look like? What do you think what mathematics is? So everything concerning motivation and self-regulation. Then we distinguish about the beliefs about mathematics and the teaching and learning of mathematics. Then we go back to this very famous work by Richardson and Thompson. And then you have the professional motivation and self-regulation. So actually you have not only what you know about teaching, you have the actual activities of the teachers as well. And here you always describe the willingness to do something is included in this whole construct of teacher competencies. This kind of framework can be found in other studies as well. It's quite distinct to other theoretical approaches, especially around in the US. The very famous theoretical framework by Deborah Ball and developed by Deborah Ball and Hannah Bass in the Learning Mathematics to Teach project. And you will find this kind of conceptual model, for example, in the German coactive study. So you have different descriptions around. It is important for a big study that you describe very clearly what you mean by your construct. Otherwise, you don't know what you are really measuring. So this kind of conceptualization is always very important. And whenever you start to read the studies, you should ask, how do they describe their central constructs and concepts? So these are the countries which participated in TEDS-M, and here you see there is quite a big group from Europe, and then the southern part of Europe or Asia. And then you see from Asia, you have as the so-called high achieving countries, you have only Taiwan and Singapore, and you have the poor achieving countries, Thailand, Philippines, and Malaysia. You already know that from the TIMSS and PISA study. And from Africa, you have only Botswana. And I want to note that Botswana is actually a country which is doing quite well within the African continent. And that same holds for Chile within South America. In North America, we have the US and Canada, And unfortunately, Canada was not included afterwards in the results because they didn't meet the quality criteria. You had to have 75% return rate, and that is quite ambitious, and they didn't meet that, which is really a big, yes, a big disadvantage. Originally, in the anti-21 study, we had South Korea included, and we had Hong Kong. And that is, of course, a big difficulty that we lost Hong Kong and Korea, but it had a problem with money, and because this kind of international studies are very expensive to participate in, and they didn't manage to get the money. So, the objectives of TEDM were international comparison of teacher education, and of course it was not used as example mathematics teacher education. And we have mathematics in bracket because we have a primary and a lower secondary level study. And of course, the primary teachers are in most parts of the world general teachers. It means they are teaching many other subjects, not only mathematics. And of course, mathematics teacher education was chosen because in math education, you can imagine to carry out such a kind of a study. If we think about history, it would be much more complicated. So, what we had over here, we had the teacher education, then we had the teacher trainings. It was a special study because they, of course, influence everything what's going on. We had the prospective teachers, we had the national conditions, and of course, we had the individual personalities, which of course influence teacher education and then led to some kind of outcome of the future of prospective teachers. So here we had the demographic background and the learning conditions. Then we had here some kind of analysis concerning the financial framework, curriculum of the schools. Then we had the institutional features and the curricula at the different universities. Here we had the demographic background and the qualification of the trainers or educators at the universities. Unfortunately, none of the results are published concerning these trainers or educators at the universities. We have a lot of data which are still not evaluated, so many more PhDs could come up with that. So, and then we had a little focus on that, the mathematical, pedagogical, math content knowledge, and we had the beliefs over here sampled. So, when we now look in more detail concerning professional knowledge, that means the left-hand side of my model, we had mathematical content knowledge, pedagogical content knowledge, and general pedagogy. And then, of course, you can imagine that you need to be more precise. So what we had over here, we had in mathematics, we had several areas. We had arithmetic, number, as most Americans would call that. Then we had algebra and function bound together. Even we as Europeans were not happy with that, because function is for us a different strand, but it was some kind of international consensus to bind together algebra and function. We had data probability, so it's not a lot what you have in this respect. We had geometry, and everything was differentiated to two levels of difficulty. If we now think about secondary teachers, you would say, where is calculus? And it had to do with the whole structure of the study. The US Americans paid a lot for the study, so they are more interested in school-related knowledge. That means everything which comes into action within school, they were less interested in really university mathematics, like calculus. So we have a few calculus items, and they are under algebra and function, and I will show you at least one university items, but it's really only a few what I would call university knowledge. Then we have concerning the pedagogical content knowledge, curricular knowledge. It means what you are doing in advance, and the knowledge about planning of lessons, that's pre-active too. And then you have knowledge classroom interaction, which is interactive. So you have three facets, And actually afterwards, curricular knowledge and knowledge about planning were bound together, and we have pre-active and interactive as facets. And concerning general pedagogy, we had different domains of knowledge too. The knowledge about teaching and learning processes, very important classroom management, and then diagnosis and evaluation of students' achievements, and it had cognitive levels, theoretical and practical knowledge. So that is actually the more detailed body behind. And if you now then look, what did we really do? You see quite a, I would say, this core curriculum, which leads, of course, to university curriculum. So you see, of course, everything concerning foundations of numbers, geometry, more or less usual curricular activities, algebra. So see a lot of functions over there. And then we see what we call stochastics, data and probability, and it does not go further than sorry, basic concepts of probability. So you see it's not very advanced. If you look at secondary level, then you see that we only include real and complex numbers, and the rest has more or less stayed the same. So, and as already said, we have the curriculum, the planning-based knowledge as one facet, and the international activities. So, what does that really mean? How can such an item look like? I have brought a few items with me in order to show you how the items look like. These are all released items. Actually, 20 items are released, so I can send that to you if you are interested in. But all the other items are not released because I still think about yes, a replication study or repeat study. I'm not sure that in any case that's the reason why we cannot publish all the items. So when it comes to mathematical content knowledge, arithmetics, advanced level, it was the question indicate for each number whether it is rational or irrational. And you had to check one box. And you see we have 4 different numbers given, and the question was whether this number is rational or irrational. And if you now look at the results, I mean, for Germany, we were not too unhappy with the first 2 results. We were a little bit surprised when it comes to see that a few, because I mean, simply the square root, and I mean, that apparently has led many Germans to think that this is apparently an irrational number. I mean, 100% should know that this is a rational number. And that's apparently something which is a very astonishing result, that you have simply a fraction over there. Why should that be irrational? But apparently because it is a fraction and it's a minus sign over there, many Germans thought that this an irrational number. So you see, the Germans did not do poorly, but they definitely could have done better. And if you look at the international results, you see that these 2 numbers were apparently really difficult. So I mean, it was a very astonishing result for us, and we had expected much better results. When it comes to MPCK, that means mathematical pedagogical content knowledge, lesson planning, we have from an advanced level, I have the following items. When teaching children about length measurements for the first time, Mrs. and here, that means you had to include a name of your country, so we have Mrs. Schmidt, prefers to begin by having the children measure the width of their book using paper clips, then again using pencils. Give 2 reasons she should have for preferring to do this rather than simply teaching the children how to use a ruler. You can shortly think about this item, what the reasons could be. It was quite a complicated one. So, and we would have expected answers coming that you want to impart from the basic ideas of measurements for the comparison of unknown quantity and known quantity, and of course you want to lead the students to the necessity to use standard units. I mean, that is the reason behind, and that would be a complete solution. And you see that this was a very complicated item. Only 9% internationally answered that rightly, and in Germany only 6%. Maybe it was too complicated or too unusual question. In any case, it was, yes, only answered by 9% of the students. So, now, what kind of results did we receive? Actually, the data were transformed to an international mean of 500, and as usual, the standard deviation is 100. So that is like it was done in TIMSS and in PISA, so these are the international regulations. And if you look, you see Taiwan far ahead from all the others. It is more than one standard deviation above Singapore. And then you see these two East Asian countries, and then you see a big gap. Then you see Switzerland and Russia, and the asterisk over there means that Switzerland, only the students from the pedagogical universities participated, not from the ones from the general universities. We would have expected higher results if all of them would have participated. Still a representative sample, but only for one kind of teacher education, bigger part, much bigger part. So, but it means their results could be higher. I mean, it's amazing how well the Russian students are doing. Thai students are doing remarkably well. It has to do with the fact that in Thailand, you only teach a subject teacher. That means the teachers, even if they want to become a primary teachers, they have to decide whether they want to study mathematics or physics or whatsoever. So they are doing a lot on math concerning already as a primary teacher. You see the US, yes, Norway a little bit above the mean, and you see that was a big surprise for the American colleagues and for us too, to be honest, that the US were better than the Germans. They all were quite sure, certain, that the Germans would do much better than the US Americans. The sample of the US American has some kind of restrictions. I don't want to into detail, but in any case, the results are as they are. The US American are doing not so poorly as most American colleagues would have expected. That was interesting for us. So then if we look at the second part, we have Poland doing not too bad. Then we have Malaysia, Spain doing remarkably poor for a well-developed country. Botswana, Philippines quite close together, Chile doing not very well too, and then we have Georgia. So you see, yes, not unexpected that the East Asian countries are on the top. The big difference between Taiwan and Singapore was a bit unexpected to us. And actually, I mean, if you look at the results of Taiwan, in this MT21 study, Taiwan and South Korea participated, and our South Korean students were outperforming the Taiwanese students by far. So, I mean, we have no idea how the South Korean students would have participated, would have achieved, but I mean, some definitely very much tough. So, if we now look at math pedagogy, then you see the situation has changed. Taiwan and Singapore are now together, and still one standard deviation above the international mean. And then you have Switzerland, which is doing quite well too, Russia, and then you still have Taiwan, it really doing very well, Norway, and then US and Germany very close together. So you see actually that Germany is not really improving comparing to the math knowledge. And here, if you look at the bottom, we actually really see a picture. We have Georgia, Chile, Philippines, Botswana, Spain, and Malaysia. And what you see is, for example, that the Botswana students are a bit better in math. In math pedagogy than they have been in math. The same goes for Chile, but still the ranking doesn't change. So that is I thought it was especially the non-existing difference between the US and Germany over here was, at least for us, a very unexpected result, and for the US American colleagues too. If you now look about the distribution of the competencies, then you see that it is, here you have the mean, and you have here the competence distribution of 75%. And then you see, for example, if you look at Chile, all of their students, 75% of their students are far below the mean. And here you see this Norway, these are the two Norwegian cohorts. A few of them are completely above the mean, but a few are really have a very strong distribution. And you see a very strong, widespread distribution here in Thailand with the two cohorts. So actually, you see that only a few countries have a small distribution of the competencies. So the question is now, what do we know about the beliefs? I mean, competencies means, on the one hand, the knowledge part and then the belief part. So, and of course, the question is, what do these cultural differences mean on the belief part? And what we evaluated in Text M were the so-called epistemological beliefs. That means the beliefs about the nature of mathematics and the genesis of mathematical knowledge. And because on the one hand you can receive results, on the other hand you need to explain them. So we referred to this cultural sociological theory of Hofstede, already developed quite a long time ago, in 1986. And he developed this very strong contrast and a paradigm with collectivism, individualism, and humanism, and we use that as an interpretation framework. Concerning the nature, beliefs on the nature and genesis of mathematics, we used a very famous distinction developed by two Germans, Frick and Turner, and they distinguish between static and dynamic view on mathematics. And actually you can find similar distinctions with other classifications as well. And concerning the beliefs of the learning process, we use the classification by Staub and Stern on the transmission versus the constructivistic view. So, what kind of results would we achieve? We actually use additive values. That means we compared the results of each country with the overall results. So, if you look at the prospective teachers from these more collectivistic-oriented countries, and this means these are countries which received as a Hofstede index a high index concerning collectivism. And these were, for example, countries like Malaysia, Russia, Thailand, and Finland. And collectivistic means that the collective, the group is very important and not the individual. It means you are always doing everything in order to please the collectivism or the whole group. You want to please your parents. That is very important, but you don't want to please yourself. It's not the self, the individual, which is placed in the foreground, but the whole group. That is the main distinction. And with these individualistic countries, and I mean it's very clear that all the European countries are really belonging to that, namely Norway, Switzerland, Germany, and Chile is strongly European influence. They are all this kind of, have a high index concerning individualism within this Hofstede classification. So, and if you now look, what do these prospective teachers from these more collectivistically oriented countries, what do they think? What mathematics look like? Then they emphasize static aspects about mathematics. It means they see mathematics as a set of rules and a theory which is important, and they do not emphasize dynamic aspects. If you look in contrast to this individualistic countries and their teachers, they emphasize the dynamic nature of mathematics. It means they describe mathematics as a process. You have to do mathematics as a process, and you need to develop new results. Problem solving, for example, is very important. Whereas here in the static aspects, you have to mainly memorize rules and see how you can learn the rules. So, and it's interesting that we had this prospective teachers from the US, from Taiwan or Chinese Taipei, however you want to call it, in Chile, who actually emphasize both aspects. So you have really prospective teachers who say, look, it's both aspects which are very important. Actually, my feeling would be from the gut that Turkey would be here something in the middle as well. But that is only my feeling from the gut. We can discuss that afterwards, what you would expect, where your own country or teachers from your country, what they would think. Sometimes it's very unexpected what you receive. I mean, it's nice if you can confirm your own thinking, but on the other hand, I mean, research is about receiving new results. So that is simply some kind of a diagram, and we see that the Norwegian students have very strongly emphasizing the dynamic orientation and really negotiate the statical orientation. Then you have Switzerland and Germany, Chile coming close, but being a little bit more in the middle. And then you see Spain, US, Taiwan, and Singapore, who are really over here. And then we have these countries, Russia, Thailand, who really emphasize the static orientation. So I mean, that is really, it's not unexpected, but if you would see these results and wouldn't have a big theory behind, then you would say, what have these countries in common? So this, going back to ground theories, can help you in order to explain data which otherwise are really very strange to say. You say, why these countries and what over there? So we always need some kind of ground theories behind in order to explain your results, which is not very easy, to be honest, to develop these kind of theories. So then, if we go back, okay, go further with the beliefs on the genesis of mathematical knowledge. It means, where does it come from? How shall mathematical teaching and learning shall be taking place? How shall it be developed and organized? Then you can see, and that might be not very unexpected, that in many Western European countries and in Taiwan, and that of course reflect the strong influence, US American and Western influence on Taiwan, you find this constructivistic approach. It says, look, teaching has to take place in the head of the students. They need to develop their own knowledge. You cannot simply take some kind of knowledge and put it into the heads of the students. It was a thinking we had, you had in Germany 100 years ago. Now we think the students need to develop their own knowledge. So that is a very dominant thinking in Western European countries. This transmission-oriented approach, it means the teacher has the knowledge and he gives it to the students. I mean, that is this kind of transmission-oriented approach. And that you still find very strongly in Eastern European countries, Poland, Russia, and you will find it in a few Asian countries like Malaysia. And I mean, these are the countries which are less influenced by Western or less influenced by Western thinking. And then you have some kind of balanced view as well. For example, Chile is such a kind of a country where you have a more balanced view. So you see it over here, especially Malaysia, very strong concerning the transmission-oriented approach, and together with the Philippines and then Russia a little bit less. So we have actually Philippines and Malaysia that are really very strong with the transmission-oriented approach. And then you have a big bunch of countries who think, look, you need to have some kind of transmission-oriented, but the students need to develop their own thinking in their own heads. And we see Switzerland and Germany Norway, we are really favoring these pedagogical approaches. Actually, I mean, we are teaching that in our universities. Look, the constructivistic approach is the only way how we can really run the education. Maybe we have gone too far. I mean, that is another discussion, but at least this is the outcome. So that is a few results about primary education. If we now come to the lower secondary study, and actually I should say, maybe I didn't make that clear enough. The primary study focused on future teachers who were aiming to teach grade 3 to 4, which is definitely primary education all over the world, because they have primary education sometimes going up to grade 6. But grade 3 to 4 is definitely all over the world primary education. So these kind of teachers who really wanted to become a primary teacher, these were meant for that. And apart from Thailand, we had this generalist approach. That means you do not study mathematics especially, but you study several subjects because you are teaching afterwards many subjects in primary education. At least it's like that in most parts of the world. Secondary study, it was quite a distinct study with only a few common items. These were the teachers who wanted to become a teacher in grade 7 to 8. So these really wanted to teach afterwards in these grades. So that 7 to 8 is actually now secondary in nearly all countries all over the world. So we will start with 2 items. I have brought a mathematical item with me, algebra, and it is from the medium level, at least we saw that. It was a classification done in advance. It's a proof item, and you can already imagine proof. Okay, empirically it will be very different. I mean, but we had classified that in advance, the medium level. So you should prove the following statement. You have graphs of 2 linear functions over here, and they both intersect the point P on the x-axis, and the question is of the graph of the sum functions always also goes to this point P. I mean, that sounds a little bit more complicated. If you do a graph, it would be quite easy. So, and the results, they're very astonishing fast. So we didn't expect a very formalized approach. We would have been satisfied, and we said, look, if you argue simply by inserting actually the values, and we insert the values, and that's it. And then you see that, of course, this function goes intersects the x-axis at the same point too. So that is not really complicated. So the international mean was 10%. Germany did a little bit better with 15%. And interesting is that Taiwan, 69% of the Taiwanese students could do this proof. And Chile, 10%. I just looked up the data for Botswana, 10% too. So, I mean, a few of them could do the items really close to the international mean. But that was really very unexpected that this item was so complicated, because they look, you only insert the values, that's it. It's not really complicated. Okay, but we were wrong. And that is one of the very rare, really university items. You have 2 matrices, you define the operation between them in such a way, and then you ask if you apply this operation to 2 matrices and receive a zero matrix, is it then true that either matrix A or matrix B are 0, 2? And you should justify your answer. I mean, it's not really complicated. We would have, I mean, you could simply argue with a counterexample, and then you see it's not true. I mean, that's the easiest way how to do that, argue with a counterexample. And that is interesting because the international mean is 18%, so it means a few, quite a high number of students were able to do that. In Germany, something about a third. Taiwan, 77%, and in Chile, in Botswana, 0%. But then in these countries, low achieving countries, none of the students, or maybe of course 1, 2, 3, 4, but I mean, actually, I mean, when it really comes to counting, then you have 0%. None of the students could answer this item. And that, of course, shows significant weaknesses mathematically by the students. Yes, and then we had a few items which were combining mathematical knowledge and math pedagogical knowledge. It means you first had to answer the item, and then you had to analyze these. So, and that was an item coming from algebra. It was the interaction level, and it was elementary as classification in advance. So you have the following question. The following item has been taken from an exercise book for the lower secondary level. Peter, David, and Jonathan are playing with marbles. Altogether, they had 198 marbles. Peter had 6 times as many marbles as David has, and Jonathan 2 times as many as David has. How many marbles has each boy? So that is the first question, and the international mean was 27%. And Germany, 80% of the students did rightly in Chile, 32. Then the next question is, 3 children, Anna, Philip, and Lucas, have altogether 198 euros. Anna has 3 times as much as Philip has, and 3 times as much as Lucas has. How much, or maybe, I think it should have been, how many euro has each child? Solve those tasks. So, and you see the percentage of the right answers goes down significantly. Only 49% international mean and 59% in Germany. And of course, the next question is, and that is then the math pedagogical item. Why is the second task more difficult for the students than the first one? Please note what might be the reason for the different levels of difficulty. And of course, I mean, if you had just, while I was reading the task, doing the calculation, I think it's obvious, here you can simply do some kind of calculations in comparison without further difficulties. And here you have to include a special another criteria. So that would have been the correct answer. For first case, a simple comparison of size is sufficient. For the second case, considerations about the ratio of the amount of euros of Philip and Lucas are necessary, and that is more complicated. So, and it is interesting that internationally only 38% of the students, of the future teachers, were able to say why the second item is more complicated. I mean, that was a little bit astonishing, because you would think, look, analyzing the difficulty of a task is something which is so important for future teachers. They should have learned that during their university study. We were not too unhappy with the German results, but I mean, on the long run, it's still not enough that only a little bit more than half of the German students could answer this question. So, if we now look at the league table, it means who did best. I mean, not unexpectedly, the Taiwanese students outperformed all the other, and they are even stronger than they were in primary. I mean, that's. And you see, it's interesting that I'm even doing better than the Singapore student. That was really surprising for us. I mean, one explanation discussed that with Russian colleagues, and they said, look, these students, we tested them in 2008. It means they entered university 2003 to 2005, something about that. They have been in school something about 10 to 15 years ago. That means these students still had received education in the very good old times, as they still had the Soviet Union, where education was very prominent. We now know that all the rich Russian parents are sending their kids to private schools, and the education in public schools is going down. So, but that was not the case for these students. So they still experienced, let's say, the good or the even excellent Russian education, which was usual in former times in Russia. So it doesn't say anything about what's really going on nowadays. If we would test now, we would expect poor results. So then you have Switzerland doing quite well as well, and the Germans are doing a little bit better than the US Americans. Actually, the distinction between the two is even significant. So I mean, that is was some kind of release for the Germans, but we still couldn't be very happy about the results. Then we see about the poorer achieving countries. Actually, there is one result which really caused an earthquake. If we look at Norway, I mean, if you know how much money the Norwegian government is spending into education, then that can't be acceptable by any kind of government. I mean, they are doing poorer than Oman or Thailand or Malaysia. I mean, it was really causing earthquake. I mean, it's afterwards reflected in math pedagogical content knowledge as well. So, and it was a strong discussion, what is going on in Norway? And one reason is what we developed and others accepted that the subject matter knowledge, mathematics, is not taught enough in school and afterwards at university. They are mainly focusing on the child and the development of the child, but the subject is really has been lost. And so they are now strongly education, more mathematics within school and within universities. So, I mean, that was not the reason why Norway changed the teacher education and school education, but it was the last push they needed in order to argue, look, something is wrong. That can't be true. So, I mean, sometimes these kind of international comparative studies have some kind of nice outcome. So if you look at NPCK, we have the same results. I mean, the Taiwanese students are outperforming all the others. And that shows that what was the discussion in former times, look, they are only doing well in mathematics and they are learning everything by heart. That is simply not true. You could see that these items I showed to you had nothing to do with learning by heart. So there is something to think about. What are the Taiwanese students or the Taiwanese education system is doing better or doing to their students so that they really are performing in such a way. I mean, they are working very hard, but there is only one part of the explanation. So then the Russian teachers are really doing very well, and they are outperforming the Singapore student. That was really, I mean, the Singaporean colleagues were not very happy about the results because they had expected them to play at the same league with the Taiwanese students, so they were a little bit astonished. One explanation for the Singapore results are, when it comes to secondary education, that they have a lot of engineering students. That means originally students who have studied in order to become an engineer and then realize that they would like to go into teaching profession. And they are entering teaching profession, but they have apparently quite narrow views on mathematics and teaching, and it simply takes them some time to catch up. So that was some kind of explanation they gave to us why they are not performing as well as they would have expected. So Germany is doing quite well. I mean, there's 522, 24, we were quite happy, although we are still outperformed by Switzerland. And you see, Norwegian students are doing poorly in MPCK, math pedagogical content knowledge as well. And apart from that, you have the same ranking list. That means Chile really far below all the others, Georgia, and then Botswana. And you really have to see that the Botswana students are apparently better educated than most African students. So, and I mean, it's quite amazing that Oman is doing so well. And here you see Thailand. I mean, now when it comes, because these students are trained together with primary students, because they all are trained in order to become a math teacher. So they don't have any advantage of that now when it comes to secondary teachers. So When we now think about what is more important, is it this mathematics or is it more math pedagogy? Then you can develop or distinguish some kind of country-specific profiles when we had a look at that. And actually, we had 3 country-specific achievement profiles which we could identify. First of all, some countries which achieved higher achievements in mathematics and in math pedagogy. And from Asia, that we have, for example, Singapore, Taiwan, in Malaysia, and then from East and Middle Europe, we had Russia and Poland. So here you see that mathematics is apparently much more important than math pedagogy. Then you have profiles where the students achieve higher achievements or higher results in math pedagogy than in mathematics. And here you see many of the European countries over there, that means Germany, Norway, and Switzerland, and interestingly enough, Chile and Georgia. So it means here you see the strong, at least for concerning Chile, you see the very strong European influence. And then you have countries where you have no special emphasis, and that holds for US, Thailand, Oman, and Philippines. And of course, that explains a little bit, or can be explained, going back to to some kind of theories. Because I mean, you have this kind of results, and you look at that and say, yes, and I mean, you wouldn't be able to publish something like that in a journal, because everybody would say, yes, and can you explain that? And if you look at these results, I mean, it's not easy to explain. Why? European, okay. Why is it that in European countries, suddenly math pedagogy is more important than mathematics? And in Asia, it's the other way around. Yes, we always try to develop some kind of explanations going back to didactical theories. Strong theory of Hochschild, for example, I already showed you a couple of minutes ago. So the question is really, how can we explain this kind of profile? And first of all, I mean, if you look back, you see that you cannot say, look, one kind of profile, for example, mathematics is more important than math pedagogy, is connected to the achievements. Because here, in this group, you have Malaysia, Taiwan, and Russia. It means Russia and Taiwan and Singapore are high-performing countries. And you have Malaysia and Botswana being low-performing countries. So apparently, this kind of, and the same holds over here. So it doesn't have anything to do with the level of achievement. It must have another cause. And it's not very easy to develop some kind of explanations. We have developed this one, and I mean, you can say, look, that is not very convincing. Why I really want to emphasize this, because you are young researchers. It's not sufficient to simply say we have received the following results. Then you receive the answer, and what? You always have to look for explanations. So, and one reason why we think that you have in these East Asian countries have this high importance of mathematics is what we call the cultural tradition of Confucian heritage culture. That means Confucianism, which was really strongly influencing all East Asian countries. It is a common characteristic of Hong Kong, of Singapore, of South Korea, and of course of Taiwan, and of course of China. So that means within this cultural tradition of Confucian heritage culture, content knowledge is very important. So whenever you talk to Chinese teachers, they emphasize how important mathematics is. That's it. You have to have a sound knowledge in mathematics, and then the rest will come. So that is what they mainly emphasize. If you discuss with teacher trainers at university, they say, look, the content is it, that's it. if you would look at these Western countries, then first of all, you cannot develop one unique explanation because Europe has such a rich cultural traditions. So, for example, we have content-related approaches, but these content-related approaches, which you mainly find in Germany and countries dominated by German-speaking influences, they emphasize content, but it is always strongly connected to math pedagogy. So we would not only say math is important, we say math is important together with didactical reflections. What we call Stoffdidaktik, subject matter analysis, is the connection of mathematics with math pedagogy. So that is really the heart of German math education tradition. And that has strongly, for example, influenced Eastern Europe. If you go to Poland, if you go to Russia, you will find a strong influence, especially in Russia, but in Romania and other parts of Eastern Europe too. And of course, the strong tradition with Switzerland. Then you have this giant, and we call that this didactic traditions of continental Europe. And next year at IGNI 13, there will be a whole strand of discussions about these didactic traditions in continental Europe, because if you look at the word didactic, I mean, the US Americans would say, what an awful word. Didactics is really something which is very narrow orientation on methods, if they even would use the word didactics. And in Europe, you have it in French, didactique, you have it in Spanish, you have it in Italian, you have it in German. It's all called something like didactique, didactic. Even in Norwegian and in Swedish, you have this word didactic. So it is a very common characteristic of continental European, pedagogical theories. And it is this strong combination of math and math pedagogy, strong normative orientation, and a strong connection to empirical research. So, and if we look, for example, in Scandinavia, there's several influences. It is Scandinavian countries are influenced by these continental European traditions. And by the way, when we talk about continental European traditions, we definitely exclude Great Britain. They have their very own traditions strongly connected to the US. So, and this in Scandinavia is mixed. It has strong connections to continental Europe, but it has very strong, traditionally very strong connections to North America. And as you may know, that of course in North America, progressive education science-centered approaches are very dominant, at least in the 70s and 80s. So that is our kind of explanation why we have these differences. And what you see over here, it's not a thing in contrast to mathematics. It's not one result and you have one hypothesis. You have a mixture of explanations which hopefully can convince the audience. So you see that it's very difficult to explain these kind of results because culture comes in. And culture is always something which is difficult to grasp. So, and now I want to close with a few selected results of relational analysis. That means we really still have to answer the question, how efficient is math education? I mean, we have now given you descriptive results. We know that in Singapore, the students are doing better than in Germany, not unexpected. So how efficient is it? So, and these are more relational results, and we have published many more, and I have actually selected these ones because they are, first of all, easy to understand and have a high relevance. For example, the first question is something like, do we have a uniform curriculum all over the world? I mean, if you do a kind of a study on the effectiveness of teacher education, you would say, look, if there is no uniform curriculum, we can't measure anything. So there must be a uniform, at least something like a cohort. But how uniform is it? I mean, if you would think about that, then you would say, okay, we expect a core curriculum in math, and we would not expect a uniform curriculum in math pedagogy, and we would expect a varied picture in general pedagogy. But interestingly enough, and we have carried out that in class analysis, that's not true. We don't have neither a uniform core curriculum in math, nor in math pedagogy, nor in general pedagogy. And of course, we have a large shared common core, especially in math, but it was not as big as we had expected. And of course, we have a huge diversity in math pedagogy and general pedagogy, but it was smaller than expected. So actually, the picture is not as clear as one would expect. So we could identify different profiles concerning referring to the learning opportunities and referring to cultural influences once more. So we had three different classes we could distinguish. First of all, when we have math pedagogy and general pedagogy. In class 1, we had this kind of basic university level mathematics. We had a very broad math pedagogical curriculum, and we had some kind of general pedagogical curriculum which was not very distinct. If we look at class 2, the main distinction is that you have here a more functional math pedagogical content curriculum. It means the math pedagogy which was taught over here was strongly related to the teaching of mathematics. That is meant over here with functional. And here we had a broad general pedagogical curriculum, but it was functional concerning teaching too. And then we have class 3, all share this basic university level mathematics with some kind of distinction, but the distinction were not as strong. And then we have a focus over here on learning and teaching methods, and then a very broad and context-related general pedagogical curriculum. So, and first of all, what we could see that half of the prospective teachers were here in this class. So, despite the many differences you had within the different countries, with Chile being at the bottom and Singapore and Taiwan being at the top, they still, the curriculum had many commonalities. I mean, that is really something which is important. And the curriculum, maybe I should mention that, the curriculum was measured by answers of the students, so it means what kind of activities they had done, what kind of lectures and seminars and practical activities they had done. So despite these huge differences, they had half of the prospective teachers had followed a more or less similar curriculum. But it is interesting that a significant group of the future teachers from Germany were in class 3. So, and that really emphasizes what is typical for Germany. We focus very strongly on this learning and teaching methods. Here is the so-called Stoffdidaktik behind. That means behind that is the strong combination of mathematics and math pedagogy. So, and that is really reflected in many learning opportunities, in many lectures and seminars about learning and teaching methods, where we combine math and math pedagogy. But then when it comes to general pedagogy, here you see a very broad general pedagogical approach, and that goes back actually to general education, Allgemeinbildung, to Wilhelm von Humboldt already 200 years ago, and this approach that everybody should have the chance to be educated. So that is over here. And interesting is that you have many future teachers from Taiwan and Singapore over here. And here, that was the reason why I mentioned this functional. So that, of course, has cultural. Of course, if we look at Asian traditions, then functionality is very important for them. They don't want to learn something only for their own sake. They or they are always looking for a function. Of course, it's a very general explanation, but the functionality is very important for East Asian traditions. And you can see it reflected over here. So, but of course, more important, I promised that to you, is the question, how efficient is math teacher education, and what is really contributing to the results of math education. And we have developed a path model. Here you see the results of teacher education, the mathematical knowledge and math pedagogical knowledge. And then you see a totally disappointing result. You see, first of all, the pre-knowledge is very important, and of course, motivation is very important. Why are they? Why do they want to study or become a teacher? But then we see composition of teacher education program, so-called coherency, and learning opportunities in math. And here you have the learning opportunities in math pedagogy, and they are not contributing. I mean, when we had this result, I was not willing to publish that. I mean, it is the death of teacher education run at in a math pedagogical department. I mean, why should we teach math pedagogy if it doesn't have any result? I mean, we looked at that and said, look, that can't be the end of the story. I mean, that is obvious. I mean, we wouldn't have published that if we wouldn't have come out of this trap. Apparently, that model is too easy, and we need to discuss these results a bit more in detail. I mean, it is obvious that if you do not have enough learning opportunities in math, you have a lot of difficulties afterwards in math pedagogy. I mean, that is a description all over the world. So, I mean, that is definitely right that learning math is important, but only learning contributing, that is something which we didn't accept. So we did some other kind of other analysis, mainly about international competence profiles. And a very important starting point is the approach by Schoenfeld, but you can find it by telling you Patrick as well, or just join her of Annie Schoenfeld and Sharon Patrick, where you said the teachers believe their convictions, they are very important. And actually, you can only predict what teachers are doing in the classroom if you know the teacher's convictions, or in the new terminology, by Schoenfeld, which is their, how does it call it? Their thinking. It is not conviction, use another word. It just was in my mind. I'll come back in a minute. So the beliefs are so important. And we then identified different competence profile. Now I know orientations. So that is the new terminology. So orientations, embracing beliefs and convictions, are important to what's going on in classroom. So, and then we developed some kind of competence profiles in which we included the knowledge and the beliefs. And I mean, that is something which we will continue to do afterwards when we come to the text follow-up study, that you cannot only reduce yourself to the knowledge, you have to bear in mind the beliefs as well. And we were able to identify different competence profiles. And first of all, we had a cognitively challenging and dynamic constructivist competence profile. And then, and these students who had a dynamic and a constructivist profile, that means they had a view on mathematics which emphasized dynamic aspects, and concerning the knowledge, how shall knowledge be developed, they emphasize constructivistic approaches. Then we could develop a profile where the students are performing very high. And then we had a group of teachers who were performing very poorly, and they hold static views on mathematics, and they hold transmission-oriented beliefs. And of course, when we talk about competence profiles, that doesn't mean that it holds for everybody. It's only more or less a grouping of countries. So this cognitively challenging, dynamic constructivist competence profiles exists in Europe and in many American or Asian countries. And it's interesting that you can identify that in Asian countries. And if you had looked at the beliefs results, then we had quite often Singapore and Taiwan something in between. So they had some kind of balanced view concerning constructivistic and transmission approach or dynamic and static approach. So, and that is what it's called nowadays the distinctive blend of East and West. That means the students or the East Asian countries are learning from the West and are integrating them in a very efficient way in their own thinking. So that is maybe this distinctive blend. So they are not only adopting or taking something over, they are learning really in a very reflective way. And of course, we have with this static beliefs, we have of course students who are performing very highly with a transmission-oriented approach in Russia and Taiwan. But it is, as said, it is a competence profile, and of course we always have exceptions. And what we could learn from these analyses are the following scope. We could identify 3 influencing factors: gender, learning opportunities, and coherence of teacher education. I mean, gender is obvious. Learning opportunities means the number of the seminars and lectures the students could attend. And coherence means that the seminars and the lectures are relating to each other. That means that first of all, I learn some kind of mathematics. Afterwards, I learn how to teach this mathematics in math education. I use this kind of mathematics and so on. Or I have some kind of general foundations in math pedagogy, and then I specialize. So coherence means really how these different lectures are connected and relate to each other. And what we could find out was that these really challenging and dynamic constructivistic competence profiles are influenced by at least 2 of the following characteristics. It means either by a high number of learning opportunities in math and math pedagogy, the coherence of the education in teachers' gender. And what we know from previous results, that is the fact that we don't have a strong gender gap between males and females in math education, but you still have some kind of gender gap. That means the females are performing a little bit lower than the males. And if we look at countries like Chile or Georgia, which were the poor performing countries, we have 90% of the teaching force is females. And that has to I was just in Chile a couple of weeks ago, and we had a group of primary teachers, 50 students were in the room, it was 1 male. Afterwards we asked them, how did you feel? So, I mean, it is, and of course, I mean, if you have this small gender gap, wherever it comes from, that the females are performing lower than the males. I mean, it has to do with entrance conditions and maybe less favorable education at school. And then if you have a dominantly female-dominated teaching force, that has consequences. I mean, you can easily explain that because this female dominance you can't identify in Asia. When you are in Asian classrooms, you see many females and many male teachers. And in America, you can't live from being a teacher. They are so poorly paid. that only females are accepting that, and both work, and the male, usually the husband, usually earns more. I mean, that is the dominant pattern we have in Eastern Europe, and we have it in South America. So very poor teaching conditions, poor working conditions, poor payment, and low acceptance within the society, social status. I mean, if as long as these countries do not change this situation, they will not improve teacher education. I mean, it's very obvious. I mean, that is what's meant behind teachers' gender. So it's a whole, you are really opening a whole discussion about society and what that means if you really want to change teacher education. We have the learning opportunities, and you see we have the learning opportunities for mathematics and math pedagogy included over here. I mean, that's the reason I have talked about teachers' gender, because I was really, when I was in Chile, I was really thinking what is going over here and how can they change their situation. But I mean, here you see it is mathematics and math pedagogy who both, the learning opportunities in both domains contribute to this very positive competence profile. So we have a very strong explanatory potential of the learning opportunities in math pedagogy. And I mean, what we really can say that it is, we have to modify now this picture, which I showed to you at the beginning, where I said, look, I mean, that can't be true, that is only mathematics. So if you look at developed competence profiles and then we ask what is contributing apart from this very global model, then you find out that it is really math pedagogy which is playing a very important role over there. So we have to really modify this component analysis and really look what are very prolific profiles for teacher education. So, to summarize, if one considers teachers' competences as a multidimensional construction, the potential effects of mathematics pedagogy come into the foreground. And so we see that we really have, in order to have an efficient math teacher education, we need to have math pedagogy. It's not only mathematics which is the dominant feature. It is important, but it is not the dominant feature. I mean, that is, from our point of view, a very encouraging result. So thank you very much. So I think we have time for discussion. If you want, I can send you PowerPoint afterwards. Yes, I have changed it.
I have email, so I can send you.
Yes.
Questions?
Remarks?
Remarks, yes.
Maybe I can. And I'm curious about the Taiwan status and the results. It's like an extreme value, extreme amount of cases and success results. Do you have any specific idea or knowledge about the Taiwan situation?
I mean, what we know from Taiwan, and that is even stronger in South Korea, is this Confucian heritage culture is really dominating. I mean, if you think about Confucius, who lived before Christ, he said education is the key for everything. I mean, he claimed education for everybody already more than 2,000 years ago. And so it is really within this society that education is so important. You have to work very hard in order to please your parents. That is very important. You have to please your parents, you have to please the whole community, you have to work very hard. Very, 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 very hard. And if you look, for example, in South Korea, but we know it from Japan and from Taiwan as well. I mean, the students are not stopping to learn when they leave school. They have this afternoon evening schools. That means the children leave the buses, the school buses at 4, and they go to the next bus, and then they learn until 10. And it is usual that they learn during vacation time, and of course, definitely on a Saturday, and maybe even on a Sunday. I mean, if you look at this working time, if you compare it to the German students, I mean, they have at least 1.5 times as many working time, as much working time as the students. I wouldn't say double, but I mean, at a certain time you need to have some rest. But they are actually really working very hard. I mean, that is one explanation. The second explanation is the selectivity. I mean, teachers are highly respected and accepted in all Asian countries. And they are well paid, but not so well paid. But they are a respected person. The teacher, that is somebody who really enters the flow and everybody treats him or her respectfully. And that is definitely not the case, for example, in Germany or many other parts of the world. I mean, the teacher is a nice person, but that's it. So, I mean, in Germany, the respect towards teachers has come down dramatically in the last 20 years. So, I mean, you have different people are really entering a teaching force. So, they are more interested in teaching profession, and they are more selected, because selected positively, and they have much better entrance conditions when they enter school. I mean, nearly all Taiwanese students have already learned some kind of calculus before they enter school and university. It means this huge gap between what's going on in university and what is going on in school is for them not as high as it is, for example, for the German students. So when you think about the description by Felix Klein, that is not so strong for Korean or for Taiwanese students. So I mean, it is a whole mixture of explanations, acceptance, working on, and so on and so on. And I mean, it's definitely, I mean, in Germany, we need to think about how to improve the people who want to become a teacher. And I mean, if you have, and I mean, we do not do too badly in this respect, but of course, I mean, Germany, we expect better results. It has to do with the fact that if we really want to earn money, you may not go enter the teaching profession. So I mean, it is really this complex relations about society. We talk about society and then we try to understand what's going on.
I wonder that how did you decide take them items that will compare such countries? Mm-hmm. How did you construct them? How did you decide that they are appropriate for all countries that enter the study?
I mean, that is a very hard decision. And actually, that was done because it is a huge study with so many countries. So we had country representatives. So Sigrid Wimble was a country representative for Germany. And they actually met. And then there were a lot of math pedagogy, mathematics, and experts on math pedagogy who decided about, I have no idea how many more items we had developed and needed, at least 3 or 4 times, or even 5 times more than we actually used afterwards. So in this math experts and math pedagogy expert workshops, the experts decide whether these items are adequate for their country. Because, I mean, you can't use an item which is not adequate for one country. I mean, then the students would have no chance to solve that. So it was this workshop in which it was decided which items were appropriate. And then afterwards, we had a very intensive pilot. And after the pilot, I think the items were reduced really by half. So then we, according to the psychometrical figures, they were then included on that, not included. So, I mean, it was a very complicated negotiation process, and actually, I mean, we had to develop many interesting items reflecting this continental European traditions. And there actually, I mean, there is one released item which reflects this continental European traditions, but there are not many. So we developed many items really being interesting from our point of view, but we didn't reach consensus within the overall group. So, I mean, these are complicated negotiation processes. And of course, I mean, it would be interesting to see whether these items are appropriate for Turkish future teachers. I mean, that is not trivial.
You had a question? I wondered that you had a result showing that for the teacher competence, the pedagogical content knowledge was not a predictor. And then the content knowledge was one of the predictors. And you had many countries that just like they're on either side of the continuum. One is for looking for more pedagogy, the other countries were looking for more content knowledge. When you put them in the same pots, so the pedagogy may be just like not showing up. So did you look for specific countries, or did you look for different groups for the predictors, or just did you look for the whole groups together for that?
You mean this?
Yeah, for this one, so we know that some of the countries are on the one side of the continuum, more pedagogy, and the other ones only just like the next, and there are groups of more content. When you look at the predictors you had, the pedagogy. So did you look for the whole countries in the one analysis, or did you just separate for different groups? For example, like let's put Russia, Malaysia, Taiwan, Singapore, and Botswana, or even Poland into one pot, and looking whether it's like a predictor for that, or
we didn't do this kind of analysis. When we found out at the first result that the opportunities to learn in math pedagogy were not contributing to the overall results, we had all countries included. Of course, I mean, it would be interesting to separate these different groups, but the problem is, I mean, if we look, I mean, you have high achieving countries and poor achieving, and the same. So apparently it is not connected to the level of achievement.
It is not, but how they look the math education is different, I guess.
Sorry?
How they look to the math education is different, I guess. I mean,
Yes.
that's one of the indicators. Might be on that. I'm not sure.
I mean, the question is really, I mean, it would be definitely interesting to see, for example, that is a really interesting group, USA, Thailand, and Oman. I mean, what do they have in common? So that would be definitely interesting, but the problem is a little bit that IAA did not do a lot of analysis. These kind of analysis I have presented you over here are the analysis we have done. That means the German group has done that, together then with Bill Schmidt from the US and with from Ray from Taiwan. But these were not done by the international group. So we have done a few analysis, but at the end of the day, you have to continue to the next projects.
I guess so.
Yeah, I mean, you only receive restricted funding. So, I mean, it would be definitely interesting to see whether, yes, these three groups would, yes, what does that mean concerning efficiency of math education? I mean, these kind of results could be done without knowing the items. So I know that a few US American groups are now doing some kind of secondary analysis. I think there are a few of them are based at Harvard. So it would be then, I mean, we'll see at the next early conference in Cyprus they will present it. So we will see whether they have looked at these kind of relations, because not knowing the items means that you have to be very global in your analysis.
Okay.
What would you think where Turkey would be?
It's close, I guess you can say, I believe. So they're both groups of mine, and that's a lot of people said content now is important. I know that a lot of people said pedagogy is important. So I believe that we will be in the middle.
Oh, okay.
That's
why
my
US American influence.
I guess so. It's like more American influence. One thing that you said, like, everything was important, but I think for this group was important, you said, whenever you're presenting your results, the results important, but the most important thing that the implications, the most important thing, the explanations. Maybe you can elaborate more on for the group that why that is so important, because it's a big problem whenever we have the papers, whenever we have the dissertations. The results are over there, but the discussions are not strong.
I mean, if you cannot explain your results, then you will simply not convince anybody, because you can always have some kind of an artifact. It means you have received the result that, for example, one group, the Russian group, is outperforming the Malaysian, but if you have no idea where the reasons are, then I would say, okay, I mean, that's an interesting result, but what does it tell me? And when we discuss in the afternoon the one paper by Tepepe and Verschaffen and Kestermans, then we will see that they actually didn't find out any results. There were no really strong results by their kind of treatments. And that happens when you are doing an intervention. That happens very often. You do an intervention and you have no results, no impact on your intervention. But that is, of course, doesn't mean that it is meaningless results. It shows that this approach didn't work and nobody needs to repeat it. I mean, these kinds of results are usually not published. Not being successful is not interesting. But of course, that is a big problem, because then everybody needs to repeat that and say, look, I repeat it, and because I hope that this kind of problem-solving approach like they used, we don't know that this approach hasn't worked already. So it is always important to convince the reader that yes, your approach was effective or not effective. And if the approach was not effective, then you should give reasons. And that could be, for example, the teachers were not trained well enough. Another explanation can, of course, be that the groups were too different. You find out afterwards that the groups are very different, so we are comparing X with apples. So, I mean, that is a quite usual explanation. And if we wouldn't have had representative samples, people definitely would have come and said, look, that can't be true. It can't be true that, for example, Russia is so above all the others, or that Germany and the US are so close. Now we have representative samples. You can't say, look, it has to do with the samples. No. But you can say, of course, and I mean, that is a very important aspect, and we'll come to that when we talk tomorrow about video studies. The results are always influenced by the measurement methods. If you ask how were the items determined, I mean, that is the most important question. How did you come to your measurement instruments? And even more strongly, what kind of conceptualizations, what kind of theoretical framework do you have behind? If you have a special theoretical framework behind, you can only receive certain kind of results, and you cannot receive other results. For example, in text M, I didn't mention that, but the general pedagogy was only measured extensively in 3 countries, namely Germany, Taiwan, and the US. And all the others did not participate in this very strong general pedagogical test component. They had problems with testing time. So, of course, you lose a lot. Whenever it comes to the development of profiles, you suddenly say, look, they are missing. So, and it means how you describe the different theoretical framework, how you develop and design your instrument, and especially what kind of items you are using, is definitely influencing your results, and you have to explain it afterwards. That is something which is, from my point of view, often negotiated and not described in papers and journals. And I always ask for that. Did you give good reasons for the results, and why did you come to this result and not to another result? And I would think if you can explain a result, even if it is a non-result, it means my intervention didn't have an impact because the instrument was not fine-grained enough, or because the groups were too distinct and were not really comparable, then you have received a result which is worse. But I mean, that is really the hardest part. I mean, when you write your paper, you start and say, okay, I have the results. And then you start and then you're happy. And then it's usually where you then come when you submit this paper most of the time. And then, I mean, I talk about myself too. I mean, it's usually that you are very happy when you have described your theoretical framework and the state of the art discussion and your instrument and the results. And then you are running out of time and you have no energy anymore to think about the results. So you submit, and the first feedback is, what do your results tell me, and can you explain it? I mean, that is definitely the first feedback. So I mean, that is, and of course, if I can explain it, then I mean, I can convince somebody and say, look, yes, I accept it. But it means this is a kind of discursive negotiation about the adequacy of results. And that will always, and I mean, if I can accept your result, then I mean, that gives that much higher validity than if I receive a very strange result and I can even not explain it. But I mean, then yes, you have it. But I mean, maybe it's not. But that is the most unpleasant part of writing the paper or writing the thesis. Whatever it means, master or PhD thesis.
Any other questions? Then shall we go to lunch?
Yes.
And shall we meet at 1 p.m.?
Yes.
And it's
Can we be selective with already?
so I think we can lock the doors so we can have it.